It's time to talk about data wrangling. What is data wrangling? Data wrangling is the process of preparing data for visualization and modeling, such as graphical displays and statistical analysis. I consider this a very important part of the course, and quite frankly, even those students who go through a graduate program and never learn R should actually learn about data wrangling. And it's unfortunate that I don't know that I've ever seen a course that was designed to help students learn how to prepare data for analysis. When we take statistics courses, even advanced statistics courses, the instructor either obtains a clean data set or cleans up the data themselves before giving it to the students. And so you learn all this statistical analysis with a nice formatted data set that is very different than what you will often encounter in the quote unquote real world. So data wrangling is the process of preparing the data. And there are some courses that I have seen that have a little unit on this embedded, but not many. This happens to be one of them. And so I'm very pleased that you are in a course where you can learn about getting the data ready in order to do statistical analysis and graphical displays. Data wrangling involves 3 steps in the tidyverse: importing, tidying, and transforming. Importing simply refers to getting the data into R. So somehow reading it from an external source, such as an Excel spreadsheet or a CSV file. In the tidyverse, importing also includes getting the data into a tibble. Tidying means getting the data into a form that is tidy. Tidying data can include creating one form of tidy data from another form of tidy data. So when we tidy data, there are really 2 major possibilities. One is the data is not tidy as it is, or the second is that we still need it in a different format even if it is tidy, so we get it from one format to another. We're going to have to learn in this unit what it means to be tidy data. Transforming, selecting, manipulating, and creating variables to create a new data frame. Data transformations are the result of using functions with existing data. Here are the 3 major steps, and those steps actually can involve, depending upon our data, a lot of complications. So what we're going to do in this data wrangling section of the tidyverse unit is we are going to learn how to deal with, hopefully, all the major different possibilities that you may encounter. And even if there's something different that you encounter that we haven't covered, I think that what we will cover will give you enough knowledge that you can adapt to that situation. So all of this is what takes place before we ever do our graphs and before we ever do our statistical analysis. And what you don't necessarily see here, but what I can tell you from experience is the reality, data wrangling takes a higher percentage of time in a major project than doing the graphical displaying, the visualization, and the modeling or statistical analysis. This is a very important topic that unfortunately tends to be underrepresented in our research methods courses. Okay, so let's get started with it. And let's start by talking about tibbles, which I've introduced you to as the primary data structure that we use in the tidyverse. So I've provided you a script called Data Wrangling in the Tidyverse, and I'd like you to follow along with me as we work through first tibbles and then methods of data wrangling. So I'm going to load the tidyverse. As we saw in previous introductions to the tidyverse, we work with special data frames called tibbles. A tibble is still a data frame, but it is a special kind of data frame that is best suited for use in the tidyverse. Let's take a data frame that's built into R. This is called iris. So here is, I'm showing you here some of the aspects of iris. Let me actually widen this window out and do it again. Okay, so here is our iris data frame. You can see that iris has to do with, it looks like flowers. Let's convert this with the asTibble function. So this is all we have to do, line 15 here. And now let's look again at iris, now that it's been put into a tibble. So you can see the same variable names, but this time we have information about what kind of variables we have here. 3 numeric variables that are doubles, 4, and then a factor. And we also see that we have 10 rows displayed, but there's 140 more rows in the data. Our tibbles don't convert the type of data. It doesn't read strings as factors. The species variable is a factor in this tibble because it was a factor in the data frame. So remember that when we used functions like read.csv, that when you had character data, that it was automatically assumed by the read CSV function. You wanted that to be a factor, so it made it a factor. Well, our tibbles don't do that. They don't convert. And you might think, oh, that's a nuisance, but actually, that's a much better way to do it. It's like the whole philosophy of R itself, that the person who is using it should be the one making the decisions. And the read.csv function makes a decision for us. When we use tibbles or read into tibbles, it does not make those decisions for us. That's very powerful. In fact, when I read in everything from the spreadsheet, I read everything in as a character and then one by one converted all the variables so I knew exactly what every variable was. You can create a tibble from scratch from individual vectors with the tibble function. Note that tibbles will automatically make all vectors the same length by recycling. So take a look at this. So here we're going to use the tibble function, tibble, in order to create my.tibble. And what we're putting in here is a x vector that is 1 through 5, a y vector that is simply a single number, and then we're putting in this function that we're calling z. So let's see what happens. Let's look at that. Here is the 1 through 5. Notice that y, we only gave it a 1, but it made it the same length as the x vector, 1 through 5. Tibble does that automatically. So then when we use the function to create the z, squaring the x and adding y, We did not get an error message like you might have anticipated in normal base R, because we didn't just have a single one, we had a 1 for every place. So we took x1 squared plus 1 to give us 2, 2 squared plus 1 to give us 5, and so on. I'll see you again as we continue looking at tibbles in part 2.